Many of the manufacturers in this industry are finally getting back to work, and fortunately most of them have recovered from the economic crisis. However, some of them did not, and it has caused some products to become discontinued, some very good products. Very sad, but at least things are coming back into normal function. One company in particular, Amax came back to work and finished development on their new motor, the ET1303. Now, I'm going to be going over these motors, or some of these motors that I consider suitable for my specific Toothpick build, this 3-inch 3S build, and also one for the 1S build, which is coming. All these motors are going to come back in stock pretty soon. And also I'm going to talk about motor sizes, prop sizes, motor quality, what to expect between motors, and what you might want to consider. That's kind of at the end. But first and foremost, let's talk about this particular class of motor. And this is a very, very small range, small class of motor that I'm focusing on very, very closely. So this is a very, very, very narrow range of motors for a very specific purpose, which is what I like the most, because that means it's kind of optimized for its intended use. And so obviously there are many of motor options. I'm just focusing on these ones which I consider the best of the bunch, the best options that are available today, right now, in this day, in this class, of which some of them are not even available yet, but they're coming into availability soon. And these motors are designed for low weight, low load, 3-inch props. Now I say low, not super ultra low, because this is the prop. This is the GemFan 3016 prop, and then there's also the GemFan 3018 prop. The difference between these two props is that one is a twin blade, one's a tri-blade. One's a little bit lighter, the twin blade is a little bit lighter, and it has a little steeper pitch on it. So the twin blade actually does have more speed, and it has significantly more efficiency as well, shockingly enough. But the tri-blade does give you a little bit more grip and a little bit more throttle control because it doesn't have quite as much pitch on it. So for these props, there's also one coming out from HQ. However, it may not be super suitable for this particular range. I'll get to that in a minute. But let's first talk about these three motors specifically. And so this was the original motor that I kind of focused on, which is the Amax ET1303 motor. And this is a motor that they had made for a long time already. And so I kind of just picked it up and gave it a shot, and I was testing a bunch of other motors in particular size ranges, a 1202, 1203, 1204, 1106, 1108. I tried many different motor sizes, a 1404, which was great, and if you want to go up in motor size, that's totally fine, except that it's super powerful and it starts adding the weight onto. I'll get to that later. And so I landed on 1303, 1304-ish size, and I went down to 1303 just to save a little bit of weight because I didn't really feel that much of a difference between 1303 and 1304. So this 1303 motor kind of was a Goldilocks motor that kind of perfectly fit. So we got them, started selling them, and people started having issues with breaking shafts. And it turns out that the shaft on this motor, I personally have never actually broken one, but I guess I don't fly hard enough anymore, but I don't know. But I have seen many people break the shafts on these 1303 motors. Now, I wish I could do something about it, and I didn't even know until many thousands were already sold, but what can I do at this point? This is something that was outside of my control. The manufacturer didn't even know, was totally unaware, and so when it started happening, kind of cut ties and stopped selling the motor and stopped manufacturing the motor completely. And so they went ahead and developed a new motor, the new ET1303. And this motor is super interesting, super cool, because it's particularly high quality, or at least that's what they're aiming for. And this is their 2305 motor, which they've sent me. This is like a $28, $29 motor for a 5-inch quad. And these motors, as you can see, they look very similar, and the small one looks very cute next to the big one because it's just a smaller version of the big one, has the same kind of bell shape. So what's actually new in this motor? This motor, if you compare it to the old motor is actually more than half a gram lighter. The old motor is 5.7 grams. It's actually the lightest motor out of all these motors here. I'm going to take the rubber band and the little tab off here and weigh it. It's actually 5.6 grams. And the new motor is 5.9 grams. So new motor is a touch more heavy, and if you take a look at the windings are genuinely prettier. They look much nicer. They are what I assume to be higher temperature windings. And what's most special about this motor is that it has a screw on. I don't even know if my camera can focus on things this small. It has a screw on the bottom of the shaft, which is kind of incredible. And it's a 1mm screw, and I'm gonna attempt to take it apart right now. And let's see if I can pull it apart without breaking anything. Yes, here you go. That is the bell. Super nifty little tiny shaft. And that is the stator. And it's literally like a scaled down motor now, where it encompasses all the parts of a much larger motor. However, I don't know if the shaft material has actually changed. I would assume that the motivation for making this new motor is to improve the shaft durability of the motor. And also they gave it a screw on the bottom, which is just super nifty. And that's a 2mm shaft, so that makes this housing, everything really tiny. Anyways, this is a very premium motor, and all the motors that they are making, Amax has always made some of the most premium motors, and I've always liked them, and you can ask anybody about them. They know that Amax makes some really nice motors, and their new line of motors is really expensive. They have like a $31 5-inch 2306 motor, which is kind of crazy, and it's hard to justify that pricing because I can't tell the difference in flight. And so I haven't tested this one yet, but I will soon, and I'll get to motor quality in a minute. But let's just look at this particular motor. So something really cool that they're doing with all their motors is that if you look at the base of the motor, you can see that it's kind of been milled out a little bit around the actual screw holes. So it actually saves a little bit of weight while keeping it as strong as it can be, which is really nice. And the magnets are stronger on this variation of the 1303 motor, and they are thicker on this variation of the 1303 motor, and that's about as far as I can tell. Nicer windings, nicer magnets, arguably better shaft. But how does it compare against alternative motors, particularly the FPV Cycle 1303 motor, which is made by RCN Power? RCN Power is another fantastic company. They make phenomenal motors. They do a great job making motors. And also T-Motor has finally, after several revisions, sent me a motor, their version of the 1303, which I originally started working with T-Motor to make the original motor before I even caught wind of the Amax 1303 motor. And I told them I want a 1303 size and around 5,000 kV, 5,000 kV. And so after 4, 5, 6, 7, I think they sent me like 8 different kinds of motors, revisions, they finally landed on this one, which I don't even know if it's for sale yet. If it is, the link will be in the description below. The original T-Motor motors that they made were incredibly underpowered and insanely inefficient. And so I was not a fan, and that's why I landed on the Amax 1303. If you compare the magnet structure of all these motors, they're not unlike one another. They all look actually very similar to one another. And I'll cut this whole review very short and tell you that the in-flight performance of all of these motors is essentially identical. And that's kind of the bottom line of all of these motors today. Low quality motors are genuinely low quality. I mean, there are motors that are so low quality, like some of these Racer Star motors are so junky that you can actually feel the difference. Their magnets are so weak that there's like nothing going on there, and the air gaps are so wide that it's just like mind-blowing how it even functions. And you can genuinely tell a efficiency and performance difference between the motors. A lot of the time, like Happy model motors, they'll have excessive kV on them to try and make up the difference, and that does help a little bit, but it also doesn't at the same time. When you look at motor review, like Mini Quad Test Bench, and you look at his metrics and statistics and everything, it's really nice to look at, and you can kind of size up motors against one another, and he has a lot more experience with motors than I do, or probably anybody in the industry looking and testing motors. So if he's going to tell you a motor is good quality, it's genuinely good quality and it's a good motor. However, bench tests are very different than in-flight performance. Having nicer windings means that you will have lower chance of burning the windings in flight, which means if you get into a touchy situation where you have excessive noise or excessive vibrations, or you bust a prop or something, you're going to be far less likely to actually burn out the motor because the windings can sustain a higher temperature. Having solid windings or single strand windings versus multi-strand windings is again the same situation. The single strand can hold up to higher temperatures. Multi-strands are arguably better in some situations if they're engineered properly, but the jury's still out on which one is genuinely better between the two. I think multi-strand is actually better because it's cheaper to get higher quality thin wires than it is to get single winding thick wires, but that's not the direction the industry has gone. People prefer single windings because it just looks so pretty on the motor. I mean, it looks like such a nice little neat wind on the motor to have a single winding all the way through the whole thing. The next you can get to the magnets. Having strong magnets is great. It does improve the efficiency of the motor. It does improve probably the torque of the motor. It does improve a whole bunch of other things about the motor probably, but it's really hard to tell the difference in flight between a very strong magnet motor and just a strong magnet motor. The air gap on the magnets and the curved versus square magnets is also very debatable. What the curve on the magnet does is it allows the magnet to actually get closer to the stator so you can reduce that air gap even more. Again, once you get to a certain point, getting that air gap smaller and smaller and smaller, while it does definitely improve efficiency and performance and whatnot, again, it's very hard to tell the difference in flight. And I've tested these things side by side on the same quad, across quads, swapped motors across quads, and I genuinely cannot tell the difference between a lot of the features on these motors, which is why I've kind of moved towards the direction of good enough. Like, if the motor is good enough, it's going to be good enough. Like, it's not going to make a difference to me or probably anybody out there if the motor costs $40 or $16, because that's kind of the going rate for a reasonable priced and good quality motor today, and I'll get to that a little bit later as well. Next are the construction materials of the motor. Best we're going to get is 7075 metal, and that's what the FPV cycle motor is made from, and as well as the our Amax motor. I have no idea what the T-motor motor is made from, but it's probably made of 7075 metal. Of these three motors, the T-motor motor is the heaviest at 6.5 grams, so it's an easy 0.7 grams heavier than the RCN power or the RCN power, the FPV cycle, or the Amax motor. The FPV cycle motor comes in at 5.9 grams, and also note that the FPV cycle motor has a thicker wire on it than the Amax motor, which I specifically spec'd out for all of the FPV cycle motors, even the 1202.5 motor, which is intended for the 1S super light build, because I don't like these little thin hair strand wires, because they can rip easier, and if you rip the wires on your motor, you're pretty much done with the motor. So I generally prefer the thicker strand wires off the motor. Also, there's one other notable difference between these motors. People always ask if I ever drop anything. There's also one other notable difference between these two motors and probably any other motor in this size class that you'll find. That specifically is the shaft. These two motors have a 2mm shaft on them, and that 2mm shaft allows you to use these 3016 props and 3018 props from GemFan that have 2mm holes on them for a very nice and solid press fit. Now, the props that we currently have in the 3016 size, the hole on the middle, if the shaft gets a little bit wet, or there's grease on the shaft, or there's mud or dirt or something on that shaft, then it could potentially slip off, and that's because when they went from the 3018 to the 3016 prop, they actually made that hole a little bit bigger. I have no idea why they did that. I forced them to make the hole smaller again, and the new batch of props that's coming very soon will have the same size hole as the 3018 prop, which is a really nice, snug, confidence-inspiring fit, and I'll show you how it goes on. You basically just push it on, and it's on, and to get it off, you got to grab the blades and kind of twist, and it slowly lifts itself off the motor, and that's how you get it off the motor. I've heard of exactly one instance where somebody actually broke the shaft of the motor free from the bell of the motor, and it started spinning around on its own separately from the bell. Just one out of so many thousands of the FPV cycle motors sold that had that problem. And so I pose you this option. You have three options now. These three motors exist. The T-motor has a 1.5mm shaft. The other two have 2mm shafts that you can use press fit props. Unfortunately, HQ has not jumped on the bandwagon of doing the 2mm hole press fit. I assume that's because they just don't like me. Particular people are against me for whatever reason, and so they pressure HQ to not do some things. Or also HQ says that there aren't enough motors that have 2mm shafts are out there for them to justify making a prop that has a 2mm hole. To which I would argue back, just because it has a 2mm hole doesn't mean it can't be used on a 1.5mm shaft. I mean, it has all common sense left everybody's head entirely. You're going to use prop screws on a 3-inch prop unless it's specifically been designed for this 2mm shaft. And the reason we went up to 2mm shafts is because you get more surface area on the shaft to grip the prop, as well as a thicker shaft so that you don't break your 1.5mm shaft. Now, the T-motor, I didn't even mention anything else about these motors because the T-motor does have a 2mm internal shaft and has a C-clip on the bottom, and all of them have bearings on the bottom. And they all function really the same. Like, I cannot tell the difference between any of these motors in flight. And if I absolutely had to judge them very closely one by one, I would say that the T-motor probably has a little bit more kV on it, and it's not quite as efficient as the other two. The other two are very close. The I tested them back and forth, and in a blind test, I feel like maybe the Amax motor might have a little bit more throttle control performance, but again, I have such a hard time telling the difference between these motors, and really the firmware on the quad is what's going to govern a lot of the performance of the quad as well, instead of the motor itself. Okay, now let's talk about motor sizes. So, like I said originally, I have tested so many motor sizes in this category to land on this sort of 1303 size. And the reason I landed on this particular size is because it seemed to fit the 3-inch light load or low load props appropriately for the size quad that I was going for. I'm going for a 100-gram all-up weight build, and that's the one with the 1303s on it, and this is the one with the Amax motors on it. And both of these perform, they both have the same firmware on them. They both have the same, everything is the same between these two quads, except for one that has a bunch of wire wrapped around it. And yeah, they both perform very similarly. Now, this is another quad I have from T-Motor, which is different. And this one just flies really wonky. I don't really know why. If I had to guess, I would say it's because of this heavy-ish canopy with this bigger camera and basically just more load on top. And so one of the ways these things fly, one of the reasons why these things actually fly so well is because the battery is actually strapped very close to the overall general center of gravity on the frame. And that's the reason why it doesn't have a battery on top. I always prefer the battery on top because it just moves the center of gravity closer to the prop line in the middle where you want it to be. But in this particular situation, I designed a lot of different frames, and I found that less weight actually helped more, and having a tighter CG that's pretty close to the real center of the quad is better than having a spread out CG with more weight that is centered on the center of the quad. And that's why the Toothpick looks the way it does. And the battery is sideways because I just found that sideways battery tends to perform better. It gives you more roll control performance than the long way battery. So this particular quad comes from T-Motor. It is a unibody design. It is strongly inspired by my discussions with them. And they were supposed to build this for me, for my store, as a ready-to-fly quad, but they went ahead and did it for themselves instead of making it for me, and then had the audacity to say that I had nothing to do with this product of theirs, which they have marketed as a toothpick. I don't know how that's possible, but do with it what you will. One other thing I want to point out about this particular quad is that when I swapped these motors on here, I actually put on, I'm not really a big fan of LEDs just because I just don't have the attention span to put them on, but these LEDs come from company Electwire RISC-X, which I've had this thing for many months now, and again, I'm so sorry for not kind of presenting it and showing it off a little bit more, but something special about this is that it doesn't actually turn on until the motors are actually spinning, which is something that's a little bit unique to LED lights in general. It also looks like it has all the colors, so I think you can actually change the color on them somehow if you just change these little solder pads. However it's done, it's a nifty little thing. It's designed specifically for toothpick So yeah, nifty little lights if you're looking for lights on your quad. I just don't have the patience for them because it just takes too much time for me to install. Okay, so to recap on these motors and then talk about size. All these motors perform the same in this particular class. If you want the 2mm press fit shaft for ease of use and lower weight, go for that. Otherwise, you can go for a screw mount, which is a PITA, up to you what you want to choose. Now, motor size. This particular motor is an 1106, I believe it's 1106. I'll never understand why T-Motor obscures their motor sizes by putting this stupid F number in front of their motors. Anyways, this one is I believe it's an 1106, and this one is a 1303. All three of these are 1303 motors. This 1106 has 43% more stator volume than this 1303 motor. However, these 1303 motors have significantly improved control performance compared to the 11 size motor. Now, if you want to think about this very logically, which is the way I've been thinking about it ever since, having a wider motor makes the prop essentially smaller, and it gives you a better torque lever on the size prop, which will, in my mind, result in better control of the prop, maybe. And then you throw in KV, which kind of screws with all this stuff together. So when you add KV to motor width, it starts getting a little bit screwy, and if you have too much KV on the motor, it kind of races through the lower third of the power range really quickly, and then the top end of the motor kind of gives up. So previously, and still today, I've said that motor height is what helps with top end RPM management. Motor width is what helps with low end RPM motor management. Neither one necessarily gives you more grunt or anything in that respect, or just performance overall, but if you wanted to talk about something like that, the wider motors tend to give you more thrust at the bottom end of the throttle range sooner than the taller motors. Now, depending on your prop that you're using and the weight of your quad, a different size motor may or may not make more sense, and this is where it gets really confusing, and there's really no easy way for me to just give you a rubric to use. But in this particular situation, very specific situation, I would say that a 13 or 14 size motor is very well suited for this low load 3-inch prop. And I say again, this is a very narrow range of use. And I found that this is to be the case with this prop. If you start running different motors, different prop sizes, and whatever, everything goes out the window and everything is different. In my opinion, after all the testing I've done, I would say that an 11.0 size motor is best for really only 2-inch props. After further testing since the original Toothpick, really only 2-inch props is what I would recommend for an 11 size motor. When you go up to 2.5 inches, you really want to move to 12 or 13 size. It just feels better in the air. Just control-wise, it feels better, and that's really what I focus on. I don't really focus on speed so much because all these things are really fast enough for me, in my opinion. Sure, I love going super fast, but really don't need to go 150 miles per hour all the time. So I'd rather have really good throttle control and really good control, like actual positional control, attitude control in the air, and also PID control and PID management in the air. And there are many ways to set up the quad such that you can help improve the way it flies. But then again, I'm getting beyond myself, because if you're an intermediate level pilot, you're probably not going to feel minor differences here or there on the quad. Once you get past a certain point, you're just looking for more and more performance, so you kind of just look at every particular aspect of the quad, trying to improve anything you can find to get that little extra performance that you want. In this particular very narrow range of performance spectrum, I have found that 13, 14, 3, 4 size, actually more like 2.5 to 4 size height, is a very suitable range for these particular low weight props. And I've gone with the 1303 size because going to, again, 1304 didn't seem to feel a whole lot better, and it draw a lot more amps, because motor height or just motor volume in general is what really sucks the amps. And so this 1106 motor, it should be less efficient than these other three motors. But what I found is that the 1106, the taller motor, while it has really awful control, It's more efficient at high speeds. It's not more efficient overall, but if you're in a race, like racing, the taller stator seems to want to be at the top range of the RPM more than at the bottom. So do with that what you will. But again, very, very narrow spectrum of use. When you go up to 5-inch and different motor sizes, everything goes out the window. And the more testing you do, the more difficult it is to apply any rule to any of this stuff. So it really is a very specific range, very specific performance kind of window that you're aiming for. Even though the majority of stuff you throw together works, when you're trying to get better and better, trying to get something better and better, you really got to like focus down on each particular aspect. So one more time, I'll get to the performance versus quality of the motor. There are some motors out there that are $40. There have been motors that have been even more expensive. I have tried some very expensive motors, and I have them. I can't tell the difference between them and a $16 motor. And that's why the motor that I'm working on right now for my store is $16, and that's why T-Motor is focusing on motors that are, again, $16. That seems to be a very nice price range where you get pretty good overall quality, and there's enough profit margin to actually make it worthwhile to make and sell the motor. And it's an overall good value for everybody. Kind of everybody wins. We've gotten to that point where everybody wins. Now, there are some things that can improve the motor performance quite a bit, and one of those things would be the bearing size. And bearing size is very important, actually. When we went from 3mm bearings to 4mm bearings on 5-inch size motors, we got a heap more durability out of the motor, and the motors tended to become quite a bit smoother, actually. And smoothness is a really hard metric to explain and convey, but it's like a skateboard wheel that has a really crummy bearing, or a skateboard wheel that has a really good bearing on it. It's really nice and like silky and smooth, and it spins real freely, whereas the one with crummy bearings is kind of rattly and kind of like it's rolly feeling a little bit, like it has like sand in the bearing somehow. This is the best explanation I have. I don't even skateboard, but I've felt enough skateboard bearings to know the difference. And so when you have a motor with a nice big bearing, it's not as taxing on the bearing to spin as fast as it is, and so it just tends to feel smoother somehow, which is also contradictory to the mechanics of the bearing. So throw that out the window, food for thought, whatever you may want to do with that. But overall, there are some motors that are coming out, particularly the Cyber motor from iFlight, which was straight up copied by T-Motor, that has a 10mm bearing, which I'm very much looking forward to. I'm looking forward to testing that 10mm bearing in a 5-inch quad, because the first time I noticed having larger bearings was that made such a huge difference on larger quads was the, aside from moving from 3mm to 4mm bearings in 5-inch, was the Avenger 2806.5, which I think has a 12 or 13mm bearing on 7-inch props, and that thing just feels so like butter smooth, the motor, when it spins. So hard to convey. I wish there was a better way for me to convey the smoothness feeling of the quad. It just feels different in the air, and I'm pretty sure it's because of the bearing, because other companies have made a number of other 2806.5 motors, and they just feel different. However, there are a lot of confounding variables in all of this, so it's really hard to compare things to one another and see what happens. But we'll just wait and see what happens. Look for specific metrics and general parts of quad motors to see if they have some of the features that you want, features that you're looking for. In particular, if you get a $16 motor, you're not really losing anything. The only thing that's a little bit lower end on a $16 motor is going to be the steel shaft, and that is a little bit lower, but at the same time, the titanium shaft is brittle. Not like I've ever seen any titanium shafts break, but it costs a lot more, and you do save about a gram of weight on the motor, and while that does help improve things quite a bit, it also isn't a drastic improvement, and even I have a hard time, or I cannot. If you give me 100 tries back and forth, I won't be able to tell the difference between a titanium bearing motor on the same quad versus a steel bearing motor, steel shaft motor on the same quad with the same everything set up. So let's go over, I'm not going to go over anything. I've talked more than enough at this point. These FPV cycle motors will be back in stock the end of next week, and I hope that you are all safe. And during this lovely time off, I hope you're spending a lot of time flossing your teeth, because it's very important. Take care. Bye.